back to some of this. We were looking at some image things, and we got through most of them. I don't know if you noticed, but most of the things that we covered down here, we covered in the chipmunk example. And I hit that chipmunk example far more thoroughly than we intended to. So most of what we've covered, you should already be kind of familiar with. The important thing to remember is that we can open a file, we can view a file, IM show or scaled show. We can look at things like format, size, and mode. We can convert the image from RGB to grayscale, essentially. We can resize the image, and then we can actually look at the image and save it out as a file. So let's see, where's my handy dandy notebook? There we go. So here's my handy dandy notebook. Yes, the idea with by the way, there's a question in the lecture questions. When we release your grades, it'll be in the form of rainbow grades, which will show you, kind of the average and your performance on each of the assignments we've given so far, as well as an overall. And we'll go over theirs. Once they're released, we will go over those. Hopefully, again, that'll be on Monday. So if we run this, all right, we run this, and we get an image, and the image looks like that, right? We started off with a nice little chipmunk eating a nut, and then we looked at it, and we looked at it. We found out it was a JPEG image. That was the format. It was 560 by 470, 560 rows by 417 columns, I think. Hopefully I'm not getting that messed up. And it was an RGB image. And then after we converted it to grayscale and resizing, it was no longer in a format, because the format refers to the file it was saved as. It's 128 by 128, and it's a grayscale or luminance image. And all of these statements we went through, I'm going to put that away for a second. All of these statements we went through, basically we would do a conversion to convert it to grayscale, and we would take and assign that value to a new variable. Then we would take that new variable and we would resize it to 128 by 128, assign that to variable scaled, and now we can look at the parameter, the scaled one, which has been converted to grayscale and saved as a file name. But in doing that, we didn't actually do anything to change the image. So if I do an IM show, pop the image back up, right? This was the original image. And what did I say? I said it's 560 columns by 417 rows, right? This is what the image originally looks like. We shrunk it down, we made it square, and we turned it to grayscale, but nothing we did actually affected the original image IM. The original image IM still looks exactly the same as it did before. Okay? So that's an important thing to note. Another important thing to note is that sometimes we want to extract out parts of an image. So I'm going to walk through an example of cropping, and I'm going to work through the example of cropping using our friend Swarm. You guys can tell me if Swarm is still a thing. Swarm was the mascot for RPI for a long time, one of the mascots. I've opened it. I've read it into an image IM. Let me do a little quick IM show. Right, that's what our buddy Swarm looks like. He's ferocious. He's a bee, right? A bee swarms. That's when they're scary, I guess. Anyway, that's what it looks like. And Swarm has the same types of things that that our chipmunk has. We can, for example, look at, putting all this stuff away. We can look at im.size. We can look at im.format. And we can look at, and size is a tuple, right? It's 600 by 800. We can look at IM format. That's a string. It's JPEG. And then we can do something like IM mode, which should give us RGB, right? And these are just member variables of the image type. So each image has these variables defined, and you can just look at them directly. Okay, so now let's look at two additional functions. The first one is image new. Now you'll notice that let me get this right. You'll notice that now instead of saying im.new, we're saying image. So this is another way to reference a method, a function in a class, is to use the name of the class. The image class is what all of our images are in. So we'll do an an image new. By the way, that's the same thing with the open, right? We have to open it. We don't have an image at this point. We have to open it using the image class. And then after that, we can use an instance of the image class. We'll get into that a little more the next time we talk about modules, because it's kind of an interesting topic, and there are multiple ways to call most of these functions. But we're going to create a new image. We want it to be an RGB image. So we will give it the string RGB, not RCB, RGB. And we want to tell it a size, so maybe we want to make it 200 by 200. Right, that is a tuple, right? So we have this function new has two parameters. Because it has two parameters, we have to supply it with two arguments. The first argument is a string RGB that says the mode of the image, and the second string is the second argument is a tuple that gives us the size. We're going to make it square, 200 by 200. And when we do that, now we've come up with IM5, and we can look at IM5. It's actually very boring. But it is basically a 200 by 200 blank black block in the center. The dimensions of this square, this black square, are 200 rows and 200 columns. Okay, so let's start exploring some more. That's the first thing we want to show you, is you can create a new image. The second thing is you can do a crop, right? The crop operation takes an image, and remember IM is our friend, the swarm, right? And crop says take out a section of the image from the point. Okay, it takes one argument. The argument is a 4 tuple. This is the upper left. This is the, this is the left side of the image. This is the top of the image, where you want to crop from. This is the starting crop points. And then the next two parameters are the bottom crop point and the rightmost crop point. So this is going to pull out something. I'm sorry. This is left, right, top, bottom. So this is going to pull out a section of swarm that is 200, right? 100, 300 minus 100 is 200, 200 wide, and 300, 400 minus 100 is 300 deep. So the crop just allows us to go into the image, and does this work? Oh, that works too. Awesome. Okay, that allows us to go, and that's going to be easier than using IM show in general. Okay, so that allows us to go into the image and crop out a part. So what we did was we took out, if this 100 is about here, and we just took out this little rectangle around swarm's eye. And that's what the crop will let you do. It lets you select an image, select a part of an image outside of select a piece of an existing image. And now we can come in here and we can even do, when we do this IM_crop, IM_crop returns an image, so we can do IM2. We can actually assign that to a variable, and now IM2 is our little cropped image. And we still haven't changed our main image. IM still is the existing image, right? We just because we cropped out the I doesn't mean that the original image changed. And the same thing with the resize. We saw the resize with the chipmunk, but I'll just throw it again up there. We can resize it to be, what, 300 by 200? That is a tuple, 300 by 200. And I also need an equal sign instead of a minus sign. Man. And now if we look at that, what we'll see is that we've taken Swarm and we've kind of scrunched him up and made him smaller and stepped on his head, I guess. Okay, and like everything, we can save this out, so we can come in here and we can do like im3.save. And maybe we want to save it as a JPEG. I'm going to call it squashed.jpg. And if we do that, we can come down and we can actually even look at that. We can see that down here there is in fact a squashed, and if we click on it, squashed is actually a squashed swarm. All right. So those are a lot of operations that allow us to manipulate images, but the thing they have in common is that none of them actually changes the image, right? IM, after all of this, IM is still our friendly neighborhood squashed guy. Okay, so IM resize, the question is, IM resize, is it just like resize left, right? Is it just coordinates? So what IM resize does is it takes this image, right? And this image, if we look at our size, right, I can look at im.size, and our size is 600 wide by 800 deep. And all resize does, all resize does is it takes exactly the same image and just squashes it or resizes it to a different size. So im3.size is 300. So we've taken that parameter that used to be 600, right? It used to be 600 wide, and we've made it half that. So we've essentially discarded half the pixels, but I expect that there's an interpolation there, so it's not discarding. It's doing another operation. But we've essentially thrown away half the information horizontally, and then we've gone from 800 deep to 200 deep. So we've thrown away 3/4 of the information on that, and we've kind of squished them down into this weird format. Okay, and again, none of these actually change the image. I'm not going to do the convert because we've already seen that in the chipmunk, and black and white is boring. So now let's look at something that's a little bit different. And I'm going to kind of end up here, but this is because this is where we want to start exploring other types of modules. And this is going to be important as we get into writing our own modules. Everything we've done so far has not modified the image. So we're going to go through and we're going to do an image.open, and we're going to open sheep. What is it, JPEG, hopefully. Right, and that's just a picture of a farmer with his furry little friend. And we're now going to create, and we can look at the size of that, im1.size, right? And the size is 600 by 396. And now we're going to create a new image. We'll call it im, and we're going to make that image.new. And we want to make this, let's see, we'll make this 600, so we'll make it just as wide, but we're going to make it twice as deep. So 2 times 396, right? So this is the original one, 600 by 396. This is going to be 600 by twice that. And how do I keep missing that? And of course, the size has to be a tuple, so make it a tuple. And it also needs a mode, so I need RGB in there. I'm sorry, I'm trying to rush, and I am. Okay, so im_new takes 2 arguments. One is the mode, and the other one is the mode, and the other is the All right, so now we have our new IM, and we can look at our IM, and all that is a blank image. But now we have our sheep, and we can do something called a paste. So we can do im.paste, right? IM is our new image, our blank image. We're going to paste from im1. Okay, so we're going to paste from im1, and then okay, we're going to paste from im1, and we're going to paste into a given coordinate. So we'll paste into 0, 0 to start with. And now if we look at im was a black image, and now it is an image with half black and half sheep. And we can do that again. So the thing we want to point out here is that this is actually changing image im. We haven't changed image im1. That's still just a single picture of a sheep. But we've changed the im by pasting into it. And we can make this a little bit more complicated even by going into and let me steal some code. And doing something even a little bit more exotic. What we're going to do is we're going to go in and import our image file. We're going to open something called Lego Movie. We're going to take and divide it up into 3 parts along the horizontal direction, right? The first one will go from 0, 0 to 1/3 of the width. The second one will go from 1/3 of the width to 2/3 of the width. And the third part will go from 2/3 of the width to the end, right? So we've now divided up into 3 blocks. We'll create a new image, and then all we're going to do is paste it in some different pieces so that we kind of mess it up and put it in a different order. And if we run this, and let me pop in here and grab this. Okay. So here's our original. It's one of the stills from the Lego Movie, right? There's Unikitty. I can't remember his name, but he's the hero. You can see Batman peeking out over there on the right. And what we've done is we've divided this up into 3 sections. If you look closely, you can kind of see the 3 sections. Okay, you guys are being a pain. You can kind of see the 3 sections, right? There's one, Unikitty's in the first part, and we cut it right about, now, where is this? Yeah, we cut it right here for Batman, right? Because this Batman gets moved over to here. We cut right before Unikitty. here is the first third, here is the second third, but we move the first third to the second third and the second third to the last third. So the only place we really see a seam is right here along this edge. And that's just, this is kind of what you're going to be doing in the lab in a couple of weeks. So it's kind of fun, but it's going to let you play with these cut and paste kinds of operations. The important thing to get out of this, though, is that there are a number of ways to write a function or a method for a class. We can write something that returns a value. We can write something that prints out a value, whether or not it returns a value. We covered that a few lessons ago. Or we can do something that doesn't return a value, doesn't print anything, but instead changes the underlying data. And that's what we're seeing here. All right, any quick questions? We are almost okay. We may survive this day. All right, let me give my little next section. While you guys have the opportunity to ask something, I'll put this little next section up. This will tell me where to cut when we actually go through. All right, I'm going to, I'll come back to the question sheet in a second. Hopefully, I've got another 15 minutes of Christian's time. Yes, go ahead.
I just have one question about trying to open up the images through Spider. Like I took the code from the lecture to try and open chipmunk.jpg and all these other images, and I just keep getting an error about the directory. And
Okay, so what you want to do, so we can specify whatever directory we want, but the way these are specified is we expect the images to be in the same directory as the program. So if you look up here, this says on mine, oops, sorry. If you look, I'm in the wrong window, so I'm moving stuff that doesn't have anything to do with it. If you look up here, there's this users west to you class. This is where I'm saving my stuff. So I have to put all of the images in that place. Okay, so all the images have to exist in that folder. And you can get the images from the lecture notes, Lecture07 images.zip. Just unzip them and then put them in the same directory and it'll work. If you understand folder structure, you can put them wherever you want and then put that path to be there. But this is the easiest way, and it'll avoid most of the problems. And it's the way it's going to have to happen on Cibity because we will know where they are, and we'll have to tell you where to put them, what file name to use.
Okay.
Okay? You're welcome.